All right, so let me continue. One joint, that's okay. So you think it is okay for you, so you can use it. And for this one, actually, we don't know the relationship. If we want to find PDF using the differentiation, so CDF here, through differentiation, we can have PDF. And also that you have the relationship if we have PMF. And this is a way to have the PMF. All right, and if we have any suitable figure, then we can use that figure to illustrate the relationship for you. Well, if you want to check the current relationship, I think you can follow the relationship on the previous page, and so that you will understand we will have this relationship by differentiating CDF to that you have the current PDF. Well, why? Actually, you can follow the previous relationship to understand the area actually maybe not the current area from negative infinity to x. Actually, it's an area for CDF, and because of area and also from negative infinity to the current interval, so you will understand from the calculus. Yes. The function here actually should be the differentiation of CDF. Okay, so you can think about further so that you can understand this relationship. Well, that's it. So up to now, we can specify function of PDF or function of PMF and function of CDF. One of the functions can be given, and so that we can know how to have some further processing. What kind of processing here? If you want to have the expected value, right? If you want to have expected value or moment, actually we can follow this kind of function. Therefore, it doesn't mean we ask you to have the sample space to have the experiment. No. This time, it won't be necessary to describe the details for the sample space and the experiment. Instead, we already have the given function, maybe PDF, EMI, or maybe CDF. Well, later we can know that application to have the calculation. That's why, from the beginning of this chapter, we know PDF and CDF, and we don't want to talk about more. I mean, talk more about the sample space or talk more about the design of the experiment. No, we specify by using a function. Well, here the same. If we want to have expected value, nth moment, or nth central moment, or variance, then we can follow the function to have the further calculation. Here we just want to know how about expected value using the notation that says mean. Well, we will follow the following calculation. And we can get back to know, yes, it's true. Follow the calculation, we will have the result, this result, and so that we have the point here. Because we have value 1, 2, 3, 4, 5, 6. It doesn't mean we'll always have the middle point. No, because of calculation. Well, finally, we will have the expected value 3.5. Well, what kind of way to have the calculation? This one. Therefore, we have the calculation of expected value. And this one is PMF. All right, so PMF with index K. So of course we have a K outside the PMF. And this way, K and PMF with index K. This way, then we will have the calculation for index K for all values of index K. And this way, we'll have the expected value. Well, if we have the expected value, you can have the calculation. 1 multiply the probability, 2 and 3, 4 and 5 and 6. Finally, the result should be this one. You can check it. Yeah, that's correct. All right, so it doesn't mean we'll always have the middle point to stand for the expected value. It's simply the expected value. Doesn't mean it is the middle value. So of course, middle value not always be the expected value. All right, so we use this way to define expected value. And actually, we will have the extension to nth moment.